Hi everybody, thanks for listening in today. My name's Dave Nettleton. I'm a program manager here at Microsoft in the data platform group. I work on the engineering team, and I'm here today to talk to you about transforming big data into intelligent action with advanced analytics. So I thought I'd start out actually with a pretty cool video showing some of the amazing things that people are doing with data and analytics in the cloud today.
Race mile 1, going into afterburners.
I can feel it coming in the air tonight.
It's human nature to go as fast as you can possibly go.
Oh Lord,
I'm not afraid of dying. I don't want to die, but I'm not afraid of it.
I've been waiting for this moment for all my life.
I just go, and I don't let up until I have to.
On the Eagle, there's over 30 sensors. They gather almost 12 million points of data. We want to figure out the best way in which for this car to run. Enter the Microsoft Cloud. We're able to take the data, automatically process it, and get the results in a time frame that was unimaginable in the past.
If you start thinking with fear, you're going to be living with fear, and you're not going to be achieving the goals that you set for yourself. Two things that I'm thinking before I take off. Let this be a testament that girls can do anything they set their mind to, and do not wreck this car.
We're processing over 2,000 measurements a second, and that's where machine learning comes in. We're going to be able to try to find the correlations that are probably not obvious and drive this project to a greater extent than we ever could have dreamed.
We will make history in 2015.
So that was pretty cool. That was a Lockheed 104 starfighter with the wings chopped off, some wheels put on, that's looking to set a new land speed record. And it's been really amazing to see how they're going to leverage the cloud and analytics to really help them with that project. In fact, that's one of the coolest things about my job, is actually working with customers every day on the really interesting things that they're looking to do with their data. And when I work with, we work with a lot of organizations, and across all parts of their business, they're really trying to leverage data in really new and interesting ways, whether it's in sales and marketing, finance and risk, customer and channel, or operations and workforce. The organizations are really looking to leverage that data to reduce costs, improve customer experience, and indeed even create net new business models for their companies. Let me give you a couple examples of some of the companies we've been working with on this to date. So ThyssenKrupp is one of the world's largest elevator companies, and they used to service their elevators in a very traditional way. They'd have a guy, I'm not sure if it's quite in a van, but he would go out to large buildings, service the elevators on a schedule, and that was the way that they ran their business for many years. They were most of the time blind to the operation of their elevators unless someone called in and said, hey, we have a problem. With the cloud data and analytics, though, they're really able to start to think about how they can transform their business. By gathering data and telemetry from elevators, they're able to understand whether in real time, whether they're actually operating, whether they're operating as expected, whether the mechanics there's any issues that are creeping in, temperatures within acceptable ranges, a part starting to wear down, there's the noise that's signaling damage might be occurring. And they're able to really leverage that data to start to predict when things might actually fail. When they can do that, they can then start to send tech crews out in advance to deal with those issues before they actually turn into outages. So they're able to really start to transform their business from one that's sort of looking in the rearview mirror and being very reactive to failure, to one that's been much more preemptive and about failures, and even from there, they can actually even start to think about changing their business model. Rather than just selling, elevators and maintenance in buildings, they can start to think about selling uptime and service level agreements around elevators. So, for example, having a 4 or 5 nines uptime for their elevators can really sort of transform how they think about their business model that they have with their customers. Another example of an organization leveraging data and analytics is Pier 1. So this is a retailer looking to offer a connected personal experience both online and in the store for their customers. They really wanted to be able to bring data from many different sources to bear to offer a really, really personal experience for their shoppers as they entered their stores, they browsed their stores, and even through an online experience. And with the power of the cloud and analytics, they're able to bring all of that data together and process it in a way that's able to give that much more connected experience for their customers. So what makes all of this possible? Well, data has been growing astronomically over the last few years. A really huge inflection as applications and devices became connected to the internet. Mobile devices are generating gigantic amounts of data. And the traditional data sources of data, while still very important, have been completely dwarfed now by this huge influx of new data. And if we sort of overlap on that, some of the technology advances that have happened at the same time, you can sort of see some of the challenges as to how people find it challenging to get new value out of all of this data. The world of data and analytics used to be fairly simple. You gather data from your transactional system, you'd create a data warehouse to answer the questions that you sort of already knew the answers to answer the questions you already knew you want answers to. So you'd pull data out of your database, put it into a data warehouse, leverage a star schema, fire queries against that data, and be able to provide dashboards and reports over your data. And that's been the bastion and still is the bastion for much of the reporting systems that exist today. But as data has really started to grow, the traditional data warehouses started to come under pressure. A new paradigm started to emerge to analyze that data, perhaps the most conspicuous of which was the Hadoop ecosystem, where the paradigm shift is very different. It says gather and store all data, transform it in place. You don't know the questions that you want to ask yet, so store all the data, and when you realize there's a new question, go write the query, analyze that data. Now, in the early days, Hadoop was really hard to use just because MapReduce was hard to use. There was very few people who could use it. But as the ecosystem matured and capabilities like Hive came in, it opened up the ability to query and ask questions of that data to many, many more people. And as data grew even further, new techniques became needed to operate over that data with the sort of speed of response that organizations want. Just doing reporting over large amounts of data and getting results in hours and days later, still very useful for a number of cases, but people are looking now for much more interactive dashboards, much more interactive exploration of data, much more interactive ability to find insights out of that data. So in memory technologies, machine learning, overall different forms of data are really technologies that are really now starting to change how people are able to get insights out of all of that data. And perhaps I'll give you an example of something here at Microsoft of how we've used big data. This is perhaps one of the little-known facts, is Microsoft is one of the world's biggest big data companies. We use big data behind all of our large online properties, so Bing, Office, O365, Xbox Live, Windows. They all have huge amounts of data and analytics backing those services to provide better experiences for customers. Back in 2009, Bing had a real trouble in really trying to gain market share in the search market. And the approach we'd been taking was to have a few people running quite complicated and hard experiments over data, taking those insights and then putting them into operation. But we just weren't iterating quickly enough. We weren't making the innovative progress that we needed fast enough. So we changed our approach, and it really came down to how could we enable more people to do more experiments over data quickly. Adopt the classic scientific hypothesis, or the classic scientific method. Come up with a hypothesis, test it. If it succeeds, great, progress. If it fails, it doesn't matter. Do another one. Try again. So to enable that, you have to have a platform and a system that lets you experiment over data really, really, really quickly. And so to accomplish that, we made a few pretty huge investments. We built a data lake to sit behind Bing that's exabyte scale. So an exabyte, if you know what a megabyte, gigabyte, terabyte, petabyte, exabyte. So this is really, really, really big data. So we built a store that would let you store massive amounts of data, and then we built a set of tools that would allow the analysis of that data to be done by a much broader group of people. Instead of it being a small group of very highly train data scientists. We wanted to open up experimentation over data to a much broader set of developers and analysts. So we built tools to make that much more approachable. And then our machine learning tools also needed to evolve as well so that we could enable a broader group of people to collaborate over quite sophisticated models. And the results really showed through in the business. In 5 years, we doubled share and went on there to continue to gain share in the market. So this was an example of Microsoft really using really big data to transform how it was able to run its business. And I'll come back to some of these technologies later on, because we're now starting to bring some of these out and make them available to customers. So another thing that we learned from this experience with Bing was that the trick really to getting a competitive advantage out of data is to be able to bring together data with the right analytics with people, and to do all of that at speed. Running a few reports through long, convoluted projects, and that require lots of meetings to set the project up, get the data warehouse set up, et cetera, et cetera. The time it takes from idea to test is too long. If it takes 6 months to come up with an idea and then to test it out, if that takes 6 months and it takes a team to do that, then you're only doing 2 experiments per team a year, and that's just too long. Can you reduce that down to weeks, even days, and then let people iterate and experiment really quickly, and use that to sort of navigate the options that are out there in the space of opportunities? So taking some of those learnings, we recently announced Cortana Analytics Suite. This was announced at Worldwide Partner Conference earlier this year in 2015. And this really is a comprehensive set of cloud services that let you transform all of that data into intelligent action. On premises, you might think of SQL Server as our on-premises SQL offering for data and analytics. In the cloud, think of Cortana Analytics as the collection of services that let you do really large scale, really powerful, really fast analytics over your data. And to enable that, we built a set of capabilities that range from information management through storage and analytics. And if I sort of walk this left to right, first of all, we need to be able to connect into all the different data sources that you have. So we need to be able to reach into the existing data sources, also make it easy for you to upload new forms of data, typically, for example, log files coming from websites and web forms, so that you can really bring all of your data into a single location. And the cloud, of course, is great for this. Storage in the cloud is super cheap. You can store lots of data, even if you're not quite sure what to do with it yet. You can store all of that data really cheaply. So we have a set of information management capabilities to help you gather that data in as your data factory for batch. Data catalog is a way to help you discover data sources initially, and Azure Event Hub is a way to ingest and scale massive amounts of event data. All of that data needs to live then in a set of scalable stores. I'll come back to these in a second, but we have some really best-in-class stores for both structured and unstructured data. And then over that data, you need a rich set of analytics tools that are approachable by a broad audience. So we've brought a set of tools for machine learning, stream analytics, through a set of very easy-to-use web-based experiences to let people operate over that data. And as part of this, we've made sure that we've carried forward and embraced all of the best learnings of the OSS ecosystem, in particular Hadoop. So in Azure today, you can walk up to our HD Insights service and spin up clusters, Hadoop clusters that are Spark, Storm, H-based clusters, and use those to operate over that data. At the same time, you can be operating over that data with some of our newer tools that we have, but we really want to make sure we embrace that Hadoop ecosystem as we go forward. And then in terms of delivering value into an organization, we have an amazing set of dashboard and visualization capabilities in our business intelligence stack. In particular, Power BI is a fully managed service for delivering and building dashboards, interactive dashboards. We can go that last mile into an organization via personal digital assistant integration with Cortana, so that organizations can really push insights right the way through to that final mile of the business user. And then we have a set of rich, also intelligent APIs that help you build apps for particular scenarios. And then we want to make sure, again, that we connect all of that power of our cloud platform back into the people in an organization and or other systems that you might have running in the cloud or on premises. So this is the comprehensive suite of capabilities that we have called the Cortana Analytics Suite. Let me now show you an example of how we use this to build an application. So I'm going to do a demonstration now of vehicle health and driver behavior. And I use this one for a couple of reasons. First of all, the car is actually quite an interesting device, and it's a bit of a stretch to call it a device, perhaps. But by 2020, 75% of cars are going to be able to connect to the internet. They're going to be able to generate gigantic amounts of information, and so it really becomes an interesting thought experiment to ask, hey, what might we do with that data? And there's some sort of things that are, somewhat obvious. Typically, vehicle diagnosis. Okay, I can understand diagnosis that's happening in the car. We've all probably heard of the little black boxes that can be attached to your vehicle for usage-based insurance. They'll track how fast you or your teenager's going, and they'll send you your new insurance bill based on the driving patterns of the vehicle. But we can also get to some more interesting things. If you can understand all the different telemetry coming in from a set of vehicles, you can actually start to do higher level fleet management operations. Or be more proactive in planning for roadside assistance. If you understand the different ways that people are driving their cars when they bring the car in for dealing, maybe you can then remap and tune the engine that suits their particular form of driving. Are they an eco-friendly driver, or do they actually try and push the car a little bit harder? You might actually tune the engine up differently based on their driving patterns. So let me switch over to a visualization of a Power BI dashboard that we built for vehicle telemetry analytics. And this has two halves to it. On the left-hand side here, we're pulling in basically real-time data of a number of vehicles that are in operation. So I've got a count of vehicles that are operating. I've got some algorithm that's running over that telemetry that tells me, hey, does this vehicle require maintenance? So I can click into this and see, I see that, based on my parameters, I'm seeing that family saloons look like they need more maintenance over convertibles. It looks like Redmond more than Bellevue. Actually, this sort of data is really interesting. There was one car manufacturer we worked with who all of a sudden had a whole slew of cars come into their dealerships for maintenance. And normally that's somewhat manageable, but the part that needed to be replaced was actually a really long lead time part. So they had a lot of cars that were literally just parked for weeks and months because they had no way to know that that demand was building up and that they would need those parts. If they were able to bring telemetry off the cars, understand and get early signals of failure, then they'd be able to start to do things, understand that, oh, hey, it looks like part X in my family saloons are starting to fail. They could start to stock those parts for those failures as people start to come in, or actually even go further, send out proactive messages to those drivers and customers and say, hey, if you want to schedule this, we can get this thing replaced. We're seeing a trend here, and we think it would be good for you to fix these parts. So we can do real-time analysis that can really sort of give you insights into what's going on in the vehicles that are out there. And then over on this side, we have what I would typically call sort of batch analysis, where we're running sort of longer-term, deeper analysis, say on a nightly or weekly basis, to provide us more sort of longer-term, like what's been happening over the last year, type of visibility into our vehicles. So in this case, we're looking at, hey, how many vehicles are being driven aggressively? How many are being driven fuel efficiently? And I can drill in again here on, say, aggressively driven vehicles by model. Again, a nice interactive dashboard. I can see, perhaps unsurprisingly, sports cars are being driven the most aggressively, compact cars the least aggressively. Looks like Seattle more aggressive than where I'm sitting right now, which is Redmond. So this is the kind of interactive dashboard that you can do some really interesting analysis with and get some really interesting insights out of your data. But what does it take to actually build a dashboard like this? So let me switch back and show you an architecture of this, and then I'll show you some of the parts that we use to build it. So as I talked about, there's two paths for data through that system. There's a data in motion path and a data at rest path. For the data in motion, I had event generator just sitting on my machine here, which is generating fake telemetry events, and that's sort of the real-time feed. But you could imagine a fleet of cars sending data. And to bring that data in, we have a massively scalable event ingest system called Azure Event Hubs. This lets you stand up very easily, massively scalable front end for data and event ingest. And then as that data comes in, we can run it through a number of different engines to do analysis on it. For example, in this case, we were running it through a Stream Analytics engine that would do some aggregation of the data and show that result back into the dashboard. For example, we were showing what's the average speed of all the cars that are being driven on the road right now? What's the average temperature of all the cars that are on the road right now? So we can do some things like that. And we can also run that real-time data through our machine learning models to do predictive analysis of things like failure, and then show the results direct into that Power BI dashboard. So that's a kind of classic real-time path of the data. And let me perhaps just show you now what that looks like with a few of the, how easy it is to do that. If I switch now, so here I was showing you, this is the real-time dashboard. Here I'm showing average speed, average engine oil, average engine temperature, average fuel. And the beauty of some of the services that we have in Azure today is we make it really easy to produce data like that. So using the service that we have called Azure Stream Analytics, I can sit on that data coming in from my Event Hub source and write a query. This is just a simple SQL query over that data. So I'm selecting various data, and then I'm creating a set of averages. So here you can see here I'm looking at average speed. So the way I'm figuring average speed is just writing an average of the speed value that's coming in from that event stream, and I'm indicating that as speed. And then I'm writing it out to another source. And the beauty of this is, functions like this make operating over stream data really, really trivial. And let me just talk about what this is doing for a second. So data's coming in on a stream of data, and you want to create an average. But how do you create an average over that data? And there's some interesting options. Do you take what we would call a tumbling window of time, where from 0 to 3 seconds is one window, 3 to 6 seconds is the next window, 6 to 9, 9 to 12, and so go like that? Or is that how you want to manage time? Do you want to take a sliding window so that every time an event comes in, you create a new window and the window slides? So there's some very interesting concepts of how you want to think about those ways to manage time when you're doing stream analytics. And so we have a set of primitives that are just built straight into the SQL language. And in this case, we're doing a tumbling window. So at every 3-second click count, we average a set of event values over that 3-second window, and then put that on the output stream. And that Power BI dashboard can then just consume that output stream and show the visualization in the dashboard. So things that can often take lots of lines of thousands of lines of imperative code, we can do very quickly in a SQL language, which works super well. So if your query works within this language, great. If you need more power and you need to drop to much more powerful techniques to give you much more flexibility, we have a range of other stream technologies as well, like Storm. As I mentioned earlier, we have great ability to spin up Storm clusters. So you could write this and leverage Storm if you wanted to go build this. But very powerful set of capabilities for stream analysis. So let me go back to the architecture slide for a second. So here we have, I'm going to look at the data at rest path. And here what we're doing, the challenge here is, so we have the real-time path where we're dealing with event data, but there's lots of other forms of data that we want to deal with. We want to bring data in from our business apps. This might be our dynamic CRM application that has my customer list in. It might be my inventory parts system. It could be a range of different data sources. And I want to bring that data into the cloud and then typically land it in some form of data lake. So we have a new service called Azure Data Lake, which I'll talk about in a second. But to date, people have been using Azure Blob as their data lake. And then you can spin up a set of processing and analysis to run over that data to do some of the analysis, like I was showing, for what does it mean to be an aggressive driver. You might train and retrain machine learning models that you use on this sort of batch path of analysis. You might take those models and republish them back onto your real-time path. even to keep them up to date with the latest data. And then often data is then staged out of this analysis area into a warehouse and then fed through a typical BI stack, leveraging something like Power BI, for example, and indeed even Cortana to connect that through to that very personal experience right there on someone's desktop. And then across all of this, so one thing we discovered was that there's a lot of powerful individual capabilities here, but connecting them together is hard. And connecting them together in a way that makes it easy to scale the system, run the system, version the system. We found that people were writing a lot of custom code to go and do that themselves. So we introduced a service called the Azure Data Factory that lets you monitor, manage, orchestrate all of this data processing at scale. I'll show you that in a second. And before I move off this slide, the data catalog is another service we have which makes it super easy to find data. One of the common problems that people have in data and analytics projects, particularly when there's large amounts of data spread across many different places, is how do I even find the data to get started with my problem? And the Azure Data Catalog provides this metadata service to make it super easy to register data sources, annotate them, and then find and discover them for analysis later. So let me show you Azure Data Factory for a second. So I'll just come back here to the Azure portal. Oh, what I'm showing you here, this is the development portal, management portal that we have in Azure. So I just showed you the Stream Analytics service there. I'm going to switch over now to the Data Factory service. And this is really interesting. That picture that I had in PowerPoint, often we'd say to people, hey, what's your architecture for your data service? And they'll either go to a PowerPoint, they'll go to Visio, or they'll go to a whiteboard and sketch it out. The beauty of Azure Data Factory is we let you actually show and visualize that, monitor and manage it actually in software. So here we have basically a set of pipelines that are bringing data in, petitioning data, and then they're doing a set of analysis. And I can see here that data is flowing through the system. The little green ticks tell me that everything's running on the expected schedule. If something went down for some period, say my network was down and a data set didn't make it, no problem. What I would actually see here would be a little red cross. And then I'm able to go and do some pretty interesting things like because we know which data sets haven't made it, if you're able to index your data by time, we were able to understand that there's a gap in your data. We're able to go back and pull just the data that matters to fix that gap. So that's pretty powerful in building these sorts of analytics applications. And from here, I can drill in pretty easily to see some of the different processing that we're doing. So I'm just digging in here now to the aggressive driving pipeline. I can see it's a HD Insight Hive activity. Double click in here. If I look at my activity script and scroll down here, and I can see, okay, this tells me then what actually was the definition we had of an aggressive driver. So it looks like if the gear's in 4th, 5th, 6th, 7th, or 8th gear, and you slam the brake pedal hard and your speed's greater than 50, then we think you're an aggressive driver. So be warned and be careful. All right, let me switch back now then to slides. So that's an example of sort of an end-to-end application that can be built using the set of services that we have in Cortana Analytics today. Let me sort of step back a little bit and go through some of the other parts that I haven't talked about yet. And if I step back a little bit, what is it that Cortana Analytics is really enabling? So we say it's going to transform data into intelligent action. Well, what does that really mean? What is it that we have to promise, the promises that we need to deliver on for that to actually happen? Well, first of all, we need to be able to say, look, we need to be able to collect and manage unlimited data. Then we need to make it super easy for people to discover insights and take action on that data. And then we need to be able to build systems that can integrate with people's existing products and work really well with the sort of the enterprise capabilities that they would expect today. Let's drill in a little further. So I'll go through each of those now in turn. So if I looked at what it takes to collect and manage unlimited data, so collecting data, I've talked already a little bit about Azure Event Hubs, this massively scalable event ingest system. Azure Data Factory is a way to manage the sort of the batch ingest of data from a number of different data sources. I'm going to dig in a little bit now on the Azure Data Lake Store and the Azure Data Lake, and the Azure Data Warehouse. So the Azure Data Lake store. So if you remember that story I told you earlier about Bing and how we built an exabyte store behind Bing to enable us to really transform how we thought about and delivered search. Well, this is us taking a set of that capabilities and bringing them out as a new public service. So this is a literally exabyte scale repository for big data and analytics. So you can store any type of data in here, don't need to transform it. We'll take care of elastically scaling the storage. We're going to build this in such a way that it's compatible with HDFS. So it's a HDFS Hadoop distributed file system built for the cloud. So a great part of this is it really helps us deliver on that promise I talked about earlier, where we're going to really embrace the OSS and Hadoop ecosystems. So any HDFS compliant project, Spark, Storm, Flume, Scoop, Kafka, you name it, will run just fine against the store. So this takes you out of the business of needing to manage storage and Hadoop storage accounts, Hadoop clusters for storage, etc. This is now a fully managed, scalable store for big data and analytics. We optimize it for massive throughput. Individual files can be petabyte in size. We spread data out over many spindles and disks so that we don't bottleneck on I/O throughput. We integrate it with Azure Active Directory so that you can now grant and deny access to individuals at the file or folder basis. And then you can spin up, as I said earlier, HD Insights, our managed Hadoop service in Azure, or even Hortonworks, Cloudera, RevR clusters, whatever you want, over this store. So fully managed, elastic scalable, hyperscalable storage system for the cloud. Just showing you a screenshot of this here. You can see here that we have under management 1.28 terabytes of data. Organized by a set of files, access. You can, grant, deny access to people as you see fit. So this service is in just recently now is in public preview. So very excited to see this go out and what people will do with this. So let me now switch over to the Azure SQL Data Warehouse. So again, here we're looking to really deliver really scalable, elastic data warehousing that lets you leverage existing knowledge and skills around SQL Server. So one of the really nice parts of the Azure platform is that we separate storage for compute. So what this means is you can store your data very cheaply. Storage is super cheap. And when you want to then spin up compute, you can just spin up the compute that you need to on demand. And this is really industry first, industry leading sets of capabilities. For other cloud warehouses, you often have to sort of pre-size clusters, decide how much storage, whether it's high throughput storage or high performance compute, and have to sort of pair it together and then use that infrastructure to run your warehouse. Here, you don't have that problem. You can just put data in the store as you see fit and spin up the compute that you need on demand. If you don't need your compute, no problem, shut down your compute, your store remains. If you want to spin up more compute, no problem, spin up more compute. If you want to elastically scale it, see here we have a little slider, you can just go elastically scale it. So you can imagine running a data warehouse at a particular size and workload for say 5 days of the week, and then say there's some peak reporting capacity that you need to do over a weekend, no problem, just scale that data warehouse up. Run that additional capacity against it, and then scale it down when you're finished. So this leverages a set of the capabilities that we've shipped as part of our on-premises appliance with SQL Server, our analytics platform system. So we're taking some of the massively parallel processing capabilities and algorithms that we have there and bringing them to the cloud. We're bringing that together with all of those benefits I was talking about of the cloud before, where I can just get started in minutes, elastically scale, and leverage all of those well-known and loved SQL Server skills that people have today to operate over that structured relational data. So very powerful, industry-first, elastic data warehouse for the cloud. So let me switch over now to the Discover Insights and Take Action. And I broke this into a couple of different sections. The first is just to talk a little bit about intelligence, which is we really want to bring a set of sort of intelligent capabilities to the cloud. And I'll talk about two classes of those, Azure Machine Learning and Perceptual APIs. As I mentioned earlier, one of the first challenges that you run into when you're trying to do analytics is actually trying to find the data and discover the data that might be interesting to you. So Azure Data Catalog is the service that lets you annotate metadata and register it for discovery and then search and find that data. And then we have a rich and powerful set of analytics capabilities over the data. I've talked a little bit about Azure HD Insight, spin up a managed HD Insight cluster, a managed Hadoop cluster, whether that be Hadoop, Spark, Storm, or HBase. You can set up and spin up a managed dedicated cluster, operates over your data. When you finish with it, you can shut it down. We've had customers who, they'd be experimenting with it with 5, 10 nodes, and then one weekend we'll see them spin up 100 nodes, and we'll be, hey, did you set the config wrong? And they're like, no, we decided to do some really big analysis over the weekend, and it was great that we just could spin up 100 nodes and go do that. So that's one of the fantastic capabilities of the sort of elastic power that the cloud gives you. Azure Stream Analytics I talked about earlier, the super easy to use SQL language for doing streaming. And Azure Data Lake Analytics is a new service that's just coming now in public preview. This is the other half or another key part of that of what we used in Bing to do data and analytics. So when you have that massively scalable store, there's a really interesting opportunity now to do some very interesting things in your analytics tools to leverage all the power of that data. And Azure Data Lake Analytics is really a new service that we're bringing that really lets you blend together some very interesting SQL-like capabilities with C#-like capabilities and really enable some very, very powerful analytics over that very, very scalable data store, the Azure Data Lake. All right, let me dig in a little bit to some of the Azure Machine Learning and Perceptual APIs parts of the suite. So Azure Machine Learning, so powerful predictive analytics in Azure. So one of the things that we often find when doing analytics is, again, it comes back to this meme I've come back to a few times, which is how can we make it easier for people to experiment faster with their data? If it takes weeks and months to come up with an algorithm, and then weeks and months to deploy it, and then weeks and months to test it, your ability to iterate quickly on your data and find new insights is just really slowed down. So what we want to do is make it really easy to build experiments and really easy then to operationalize them. And this is probably one of the most important value propositions of Azure Machine Learning. We have an ML Studio that makes it really easy through drag and drop to author very rich and very powerful experiments. And then with just a single click, you can actually take that experiment and deploy it as an endpoint. So via ML operationalization, it completely removes the deployment friction. You can just click a button, cleans up the experiment, deploys it into our cloud infrastructure, and then from a simple API endpoint, you can call that data as part of your analytics application. Makes it super easy to build and deploy these applications. No more I write something in R, I hand it to my IT guy who looks at it and says, hey, I don't have R on my servers, what am I going to do? I have to rewrite it in some new language, errors creep in, it takes a long time. Nope, click of a button, new APIs are deployed. As part of the Azure Machine Learning, we're also bringing a great and very powerful set and best-of-breed set of algorithms. So there's algorithms that we've built ourselves inside of Microsoft, again, as part of Bing, Xbox, and other services. And again, fully embracing a set of open source OSS capabilities, in particular R and Python. These are amazingly powerful languages. They have huge ecosystems of very powerful functions built out for them. So we want to fully embrace those and make it really easy for people to leverage that learning, bring it into our ML Studio, and then deploy that really, really easily. And if I show you an example of that in this screenshot, here I'm showing a screenshot of Azure Machine Learning. And it's basically a very drag and drop user interface, so we want to make it very approachable to a much broader set of users. And really all I'm taking is I'm just taking an R script and then doing some pre-processing of data before I feed it into that R script and then executing that R script. So I can walk up to Azure Machine Learning, There's a free tier, get started immediately, some great learning, some great online tutorials to get started. I can take an R script that I might have, just drop it in really easily into that user experience. And then the button down here, circled in red, this is what I was talking about earlier about ML operationalization. I can just click a single button, and that R script will now be deployed as a web service, as an API that I can now call in either real-time or batch mode to do ML scoring. So I can tie it into an application that I have, a web service that I might have, etc. So very simple, very powerful set of capabilities. To make it easier for people to get going with machine learning, we've done a whole range of different things. I threw some screenshots of them up here. So we have the Azure Machine Learning, now the Cortana Analytics gallery, where we make it really easy to share and discover experiments, share and discover machine learning APIs. So very easy to see a set of experiments that people have built out. You can just deploy them really easily into an application, into Azure ML Studio, and experiment them with yourselves. We also have a set of finished APIs. So this one here is for churn prediction. So I can use a finished API super easily. There's a web endpoint. I feed it some data. It calculates whether or not the likelihood of a customer or a player, a subscriber, or a user to some web service is likely to churn. You can feed in a set of interesting data, call this API, and it'll give you a result right back. So as well as a set of APIs in our gallery, we've also taken a set of APIs that we've used in services, again, like Bing, and we're bringing them out and making them available for everyone to call as part of their applications as well. So an example of one of those, and I'll come back to this a little later, is face APIs. So just take that picture on the right. We have a set of APIs that make it super easy to do things like identify the faces in this picture, verify if faces belong to the same person. We can detect the gender, the age. We can understand whether take a picture and then look against another set of pictures to find out if that person shows up in those pictures. So these would require massive amounts of coding, custom work to go do. With Cortana Analytics Suite and our perceptual APIs, we bring that to you as basically a set of finished web services that you can just call super easily as part of your application. So really, really powerful stuff. Okay, let me talk a little bit about now enterprise productivity and readiness. One big part of what we offer here is making it really easy to stand up and run analytics applications. As I said earlier, if you want to run analytics applications, sometimes you know exactly what it is that you want to do. Great. Well, you want the power of the cloud to be able to often deploy and scale those. But the other beauty is it's really easy to build applications quickly with the cloud and experiment really, really quickly. And to do that, we really need to be able to offer this fully managed set of Elastic services. So we make it really easy to deploy these big data and advanced analytics projects. You don't have to install any hardware, tune, config anything. This is a fully managed set of services. There's no infrastructure or software to manage. And you can very elastically scale your storage or the number of compute machines from tens to thousands. You can scale them up, scale them down. And in terms of managing those applications, two things that I'd talk about. So the Azure Data Factory, which I talked about earlier, is a way to get data in. With that monitoring and management experience, again, makes it a really powerful way to monitor these analytics applications. Typically, an advanced analytics application will use a number of different services to compose together quite a sophisticated solution. And so bringing data across those and managing data across those different apps is real hard work. So we're trying to take all of that hard work out of the way so customers can focus on their productivity. So something like Azure Data Factory helps you build and manage those data pipelines. Also, as part of an enterprise, you really want to deliver insights right there into every person in the organization. And that's where, again, Power BI and Cortana come in. With Power BI dashboards, it's very easy for everyone in the organization to see and share insights over data. And with Cortana, we're able to go even further into a much more personal experience through the personal desktop assistant in Windows. And And again, just as an example here on the screen, I've showed an example of what it takes to just deploy a set of all of these services. So again, these are fully managed services, super easy to deploy, provisioning event hubs, provisioning stream analytics, provisioning Hadoop clusters on Linux. If I want to do that, provisioning Data Factory, just walk up to our Azure services, provision them directly and start using them immediately. So I thought I'd give you a bit of a fun example of how we, Microsoft, have actually seen the benefit of this set of cloud services ourselves. I don't know how many of you have seen this website, howold.net, but let me just show you that for a second. So this was a website we launched to do a demonstration build. So we build a website, takes a set of photographs. We put some here, stock ones. You can also upload and use your own photograph. So I'll just pick one of these stock photos and use this photo. And it uses those face APIs that I was talking about earlier to detect the faces that are in the picture, the gender of each person in the picture, and also their age. And it was the story behind this is kind of fun. So we built this to show how easy it is to build these applications. What we did not expect, we really did not expect this, was we went in 7 days from 0 to 50 million users. 50 million users in 7 days. It took the telephone 75 years to get to 50 million. To get to 50 million. Facebook 3.5 years. Even Angry Birds 35. We did it in 7. In fact, we did it so comprehensively and so quickly. Facebook and Twitter thought they were getting 0-day attacked and blocked us. This was a ridiculous phenomenon. We were on all of the daytime TV shows. People were doing all sorts of crazy stuff with it. It was this amazing phenomenon. I've shown a couple of graphs here. So Joseph gave the keynote at Build. Here we go, right at the end of April, and just showing you here some of the peaks that we ran into. Within a couple of weeks, 1.2 million visitors an hour, 7 million images an hour. This thing went completely viral. Some of the lessons we learned from this, which were some were expected, some were unexpected. One lesson was be prepared for big data, even if you're not expecting it. So we built a little app. We were expecting this app to be useful for an event and show, hey, look, it's easy to build an app. This app actually was built by one developer over 3 weeks. They were able to use a set of the Azure services to create a website, use the face APIs, wire various data in on the back end. 3 weeks, one developer, they built it pretty quick. So it was a great demo for this event. But all of a sudden, when it started to really take off, because we'd built it with the cloud in mind, we were actually able to do a whole range of elastic scaling. At one point, we actually peaked at 1,600 cores assigned to this app. We had no outages throughout the whole time it was up. We had live metrics and monitoring operating over the data. We sort of wanted that ourselves because we were like, hey, we always like to know how exciting and how good these things are. But we were seeing it was going really, really crazy. Then we would see dips. And we were like, hey, what's going on? We were able to investigate. We saw very quickly that Facebook and Twitter had been blocking us because they thought they were getting denial of service attack from this monster site that was bombarding them with requests. So after an hour or two, we were able to identify that and address that. It was a really interesting experiment and experience for us to just see how powerful the cloud is to let you build and scale these applications. And what wasn't really a big data problem, just all of a sudden became a big data problem for us. And then this also comes back to that meme I've been talking about through this. It's just really easy and sometimes surprising to go and experiment with these sorts of applications and these sorts of services. So really want to encourage people to think about how you can experiment with your data, test and learn, turn things around fast, try new things that you haven't tried before. It's so easy to do now. And if the thing takes off, no problem. Elastic Scale takes care of a whole bunch of scaling that system for you. We also learned some other interesting things from this service. This is one of my favorite ones. Turns out shaving makes you look younger. So we find people doing all sorts of crazy things. We'd have marketers putting their, might be a bourbon that'd be like aged 12 years, and they'd put the little yellow sticker there on top of it. saying, yep, we got it right. People were doing all sorts of crazy stuff with this. This is one of my favorite ones. People would, they'd have a beard, start shaving it off, they'd take photos of themselves at different stages, and they discover that, shaving looks like it makes you younger. I don't know if this is true always, so, don't try it always. But, very fun experience, very fun experiment that we ran. Okay, let me start to wrap up now. So in this talk, what I really wanted to do was talk about how big data and advanced analytics can really be brought to bear with the power of the cloud. We introduced earlier this year the Cortana Analytics Suite, which is this fully managed set of cloud services that we use to really power that intelligent cloud. And it really is fully an end-to-end platform for big data and analytics that we really want to use and see customers use to transform data into intelligent action as part of their enterprise. So I'd encourage you to go and try these services, go build applications, experiment, learn, have fun with what you can do with data. And if you find something cool, get in touch and let us know what it is that you've done. Thank you very much for taking the time to listen in today. Thank you very much.